Now we'll solve some more problems on circular motion. Let's solve a problem on uniform circular motion. What is uniform circular motion? Speed of the particle is constant, body is moving in a circle at constant speed. So one particle is moving in a circle with a time period of 4 seconds. That means it completes the full circle in 4 seconds. We have to find the centripetal acceleration. You see, there will be only one kind of acceleration, that is centripetal acceleration. Radius of the circle is say 10 centimeter. So how to find the centripetal acceleration? Time period is known, radius is known. So how to find? So centripetal acceleration, there is only one formula. What is that? Centripetal acceleration equal to v square by r. And what is v in terms of omega? Omega is angular velocity. V is r omega. So we can use this equation here. We'll get r square omega square by r. One r will get killed. So centripetal acceleration omega square r. Now what is omega in terms of time period? Omega means angular velocity. How much angle it is moving in 1 second. That is angular velocity. Full circle is 2 pi radians. And 2 pi radians it covers in a time period. Therefore, angular velocity omega is given by 2 pi by time period. This is the angle rotated in 1 full revolution. This is the time to complete 1 full revolution. This by this gives us angular velocity. So this into r, omega square r will give us the centripetal acceleration. Now, 2 pi whole square is 4 pi square. Radius here is 0.1 meter, right? Not 10. And time period is 4 seconds. So we get t square 4 into 4. 1 4 will get killed here. Pi square is 10. So pi square and 0.1 cancel. We get the answer as 0.25 meter per second square. This is the centripetal acceleration. Remember, pi square is how much? Pi square is 10 approximately. Pi square is also approximately equal to g. So these approximations we can use for calculations. Pi square is approximately equal to 10. Pi square is approximately equal to g, and that gives us the answer 0.25 meter per second square. Right? So this was the question on uniform circular motion. What you need to remember is centripetal acceleration is v square by r. V is r omega, therefore acceleration is omega square r. Omega is 2 pi by time period, and that square into r gives us the centripetal acceleration. That's all. Now let us solve one problem on non-uniform circular motion where velocity will be changing with time. In this next question, v is a function of time and v equal to 2t. Whatever is the time, velocity is 2t. T will be in seconds, v is in meter per second. This is given in the question, v equal to 2t. And let us say the radius of the circular path is 20 centimeter, which is nothing but 0.2 meters. And they want us to find the radial acceleration, that is the centripetal acceleration, and also the tangential acceleration. So that is the question. Right? So how to solve this question? We need radial acceleration and tangential acceleration. This is non-uniform circular motion. In non-uniform circular motion, we have got a centripetal acceleration given by v square by r, and a tangential acceleration at, that is the rate of change of speed dv dt. So these are two equations we need. One equation is centripetal acceleration is given by v square by r, and the tangential acceleration is rate of change of speed, and that is dv dt. Right, that's all. Now, they want us to find out the centripetal acceleration and the tangential acceleration, say at a particular time, and time is given as, say, 3 seconds. So time is 3 seconds given in the question. Okay, so time is given as 3 seconds. Now, how to find radial acceleration? V square by r. V at 3 seconds will be how much? 2 into 3. So V3 will be 2 into 3. We are putting t as 3 seconds. So we get 2 into 3, that is 6 meter per second. And therefore, the centripetal acceleration will be this V3 square by r. V3 is 6. So 6 square, and the radius we have taken as 0.2 meters. So 36 by 0.2, that is equal to 180 meter per second square. So this is what is the centripetal acceleration, v square by r. We have to find the velocity at t equal to 3 seconds. So we found that at 6 meter per second, and therefore the centripetal acceleration became 180 meter per second square. Now to find the tangential acceleration. Tangential acceleration what? Rate of change of speed. This is the speed, v equal to 2t. So therefore, the tangential acceleration at will be equal to dv dt. Now to differentiate this, so what will I get? d dt of 2t, and 2 is a constant, therefore 2 will come out, and you will get dt dt, that is 1. So answer is 2 meter per second square. Right, that's all. So what all things we learned in this question? We learned that a equal to v square by r, right? V is r omega, so acceleration, that centripetal acceleration is also equal to omega square r. Omega is 2 pi by time period, so that is the equation we get. In the next question we learned that in non-uniform circular motion, a body has got two types of acceleration, radial acceleration and tangential acceleration. Radial acceleration is v square by r, and tangential acceleration is dv dt, where v is the speed. Here v is given as a function of time, the speed equal to 2 times t, right? So tangential acceleration, remember, is rate of change of speed dv dt, and centripetal acceleration is v square by r.